So in this prototype, we have a conventional coil, which is going to perform negative work with created electromagnetic field energy. And we have a Regenex coil that is going to perform positive work with created electromagnetic field energy. And we have our input source, and when we place the conventional generator coil on load, which is going to supply power to this light bulb, about 10 watts, we're going to see the load current sine wave. You don't have to worry about trying to show it, because other videos show it. When this light bulb goes on, the system speed is going to go down because negative work is being performed. The prime mover, which is an induction motor, is going to consume additional energy because it's trying to maintain whatever the set speed is. And so Richard, what I'm going to get you to do is you're just going to read the speed of the system, okay, when it goes into conventional generator mode and then Regenex mode, okay? Yep. So you just need to point this at that little reflective thing, okay? So if you guys want to come closer, you're welcome to. If you want to read the meters or whatever. It's up to you. So what we're going to do is we're going to bring the system up to idle on no load, and we're going to establish rotational equilibrium. And rotational equilibrium is where the net power in the drive shaft is 0, because the torque in the drive shaft is 0 and the net power in the drive shaft is 0. It's going to be sitting at a steady state speed. The power in the drive shaft, that's at rotational equilibrium is the same that's in that drive shaft, which is at static equilibrium. Static equilibrium, dynamic equilibrium. In both cases, the drive shaft has no energy in order to perform work. Okay? So the conventional generator will perform negative work, and the Regenex generator will perform positive work. Can you hit that little switch there? Well, I'll do it. No. So we're just going to let it go up to steady state speed, and so this prototype is designed to show the load current delay between a conventional coil, where the reaction is instantaneous, and a Regenex coil, where the reaction is not instantaneous. So what's our speed there? 3500. Okay. well, no, 3492. Okay, 3492.
Yeah, 3498, 97.
Okay, steady though, right?
Yeah.
Okay, so now we're gonna put the conventional coil on load. Now I'm gonna ask you a question. Can you please decelerate that motor without energy?
No, you need a motor. Yeah, you need energy of
Even if you put your finger on it, even if you, the only way to decelerate that system is to put energy into it somehow, right?
I'll go to it.
Okay. So you can't decelerate the system without energy, right?
That's right.
Okay.
In one form or the other.
Yeah. So now we put the conventional generator coil on load. We're delivering 11.3 volts through the load, and the current is 0.9 amps. Now what's the speed now?
Lower, it's 34. 74. 3478. It's a little lower. Just a tiny bit. Hardly.
Okay.
So down by 20 RPM, I guess.
So here we have the low current sine wave for the conventional coil. Now again, if I asked you to accelerate the system, would it be possible to accelerate the system without energy? No. And so now we're going to accelerate the system without increasing the input.
Right.
We're going to be harnessing the subatomic created energy that's currently performing negative work. We're going to use that energy to accelerate the system while increasing the power generated through the load. So now we're delivering 12 volts to our load. The current through our load is 0.94 amps, so the power has gone up, and the speed has gone to what?
3504.
So has the speed gone up?
It's gone up by 26 to 30 RPM.
Okay. So the speed has gone up, but we're not putting any additional electric power into the motor.
You just close the loop on your coil, right?
The Regenex coil.
Yeah.
But I'm going to put, there's another Regenex coil in there, so now I'm going to engage the second Regenex coil, and we're going to increase the speed again. Okay? So what I'm doing is, what we did with this motor was we short-circuited the coils. Okay? When you short-circuit the coils of a generator, you have the maximum current flow through the coils, which produces the maximum negative work.
Yeah, it was really hard.
Okay. So what we're doing with the Regenex coils is the opposite. We're short-circuiting the Regenex coils, and that's when we get the maximum positive work.
Okay. Yeah, gone up 5 to 6 RPM.
Okay, so now, this is the low current sine wave for the Regenex coil. Now it's 90 degrees, it's delayed by 90 degrees. This is the low current sine wave. This is the blue coil is the delay for one coil. And that's the delay with two coils. So the low current sine wave for the Regenex coil because it's delayed in the time domain, the electromagnetic field energy that's created around the coil is performing positive work. So we're back to regular generator operation, and the speed is going down.
No coil on.
Well, the conventional coil is on, okay? So now I'm just going to take the conventional coil off, and you're going to give us the
Will that be the original value?
idle speed again.
Yeah, it's a little higher than,
Yeah, just read the number.
yeah, 3503.
Okay. So now I'm going to accelerate the system. I'm not using the conventional coil to decelerate. Just going to use the regenerative coil to accelerate as much as we can with this prototype. Okay. So now you can tell us what the RPM is.
35 plus 23. 35, 23.
So has it gone up?
Yeah, by a big chunk.
Okay.
20 RPM roughly.
So we've increased the kinetic energy of the system while generating electricity with the regenerative coils, and we decreased the kinetic energy of the system with the conventional coil when generating power below. Correct?
Correct.
Okay. So, again, this prototype is meant simply to show the load current sine wave for a conventional coil and the load current sine wave for a regenerative coil, establishing that the regenerative coil's load current is not occurring in the same time domain as the conventional coil. If it was, it would also perform negative work. And because it's not, it's performing positive work. So, and when we engaged the regenerative coils, we were actually demonstrating the regenerative quantum motor. Okay, the regenerative quantum motor performs positive work with electromagnetic field energy that is being created at the subatomic level. Okay, so this prototype here is a larger version, a more powerful version of this one, and it's pretty obvious when you see the quantum motor in action. It's very obvious. So again, to restate, this is our input energy, our energy input source. We're monitoring the input energy to ensure, to ensure that we're not adding additional input power into the prime mover, that we're not adding power into the coils. This is the input side to the motor, and this is the output side from the coils. And so,
Yeah.
oh yeah,